So now we're going to look at the first section of our notebook, which is on the distributions of an estimator. So we're first going to import all the libraries that we need for this notebook. Just in case, the notebook can be found on GitHub on the address over here. So I'm going to run the code to import all the libraries that we're going to need. And we're going to look at the distribution of an estimator. Now, all estimated parameters have a distribution. And you may, for instance, recall that some parameters have, let's say, a t-distribution. So when you want to test whether these parameters differ significantly from 0, you're going to do a t-test. In machine learning, the models are so complicated that there are no analytical expressions for the parameters in these models. Therefore, it's important that you learn how to simulate such distributions yourself. And to get used to this idea of simulating distributions, we're going to start with simulating distributions that you actually know, where you actually know what the analytical expressions are. And in this way, you get a sense of how this works and how it compares to the analytical expressions. And we start practicing some Python code. So we start with the simplest possible distribution, which is a uniform distribution on 0, 1. Then we're going to draw a sample out of this distribution, and we're going to calculate the sample average. And the point is, we want to know what is the distribution of the sample average. And to get an idea of what this distribution is, we're going to use the following trick. We're not just going to calculate the average of one sample, but we're going to calculate the average for 10,000 different samples. And these 10,000 different sample averages give me a distribution. And that is then the distribution that we're going to plot. So let's begin. So let's first look at how to draw random numbers out of a uniform distribution. And here we're going to use TensorFlow. As you can see here, I have imported TensorFlow as TF. So if I want to use TensorFlow, I'm using TF here, then random, and then uniform. So if you want to know how this function actually works, you can use the question mark after it. Run the code block. This also works in Jupyter Lab, so that's not for just for Emacs. And it will explain to you how you can actually run this function. It gives a couple of examples. So let's say that we want the sample size equal to 10. So then we can call this function with sample size, and we're going to draw from the uniform distribution between 0 and 1. And then what we want is the average of this thing. So here we have one draw, and the average is 0.43. We can do it again. Now we have an average of 0.5. Yeah, but the point is, of course, that we don't want to do this 10,000 times. So I'm going to define first the number of simulations that we want, and simulations, and we're going to make that equal to 10,000. Then I'm going to generate the data, which is going to be NC simulations. And just to get the sense of what's going on here, I'll see what the shape of this thing is. Oops, I made an error. So what is going wrong? I have closing bracket, too many. So what I'm saying here is that this variable data is generated by having this draw from a uniform distribution, where I'm going to have 10,000 rows and 10 columns. Yeah, so the shape is 10,000 rows, so that's the first dimension, and we're going to have 10 columns. So now I have this data set where I can calculate for each row the average of my sample of 10 observations. And that will give me the sample average and the distribution of that sample average, because I have 10,000 of these things.